Hello, good evening. Let's start. Hello, good evening. Let's start. Am I visible? Hello, good evening. I hope I'm visible. Screen is visible. If yes, let's start. Hmm. Good evening. Good evening. Let's start. So yesterday we saw classification of cardinal data into discrete and continuous. Discrete means data which can take only specific or countably infinite values, whereas continuous is data which can take infinite values, which is uncountably infinite. Okay, now let's see how we prepare frequency distribution for discrete and continuous data. Then we can go to diagram, then the chapter is over. Okay, we'll study only that much today. From tomorrow we'll start with central tendency. So now concentrate. Fine. Frequency distribution. We had considered one example yesterday. Let me open it again. This weight of 36 BBA students on page number 16 or 17, this. Let's take this as our basis and let's try to do some calculations. Good evening everyone. Let's try to do some calculations accordingly. Now concentrate. First let me write whatever is given, weight and number of students. Let me write it here so that we can do something with that. Wait just a second. Weight and frequency, right? Okay, 44 to 48, 49 to 53, 54 to 58, 59 to 63, 64 to 68, 69 to 73. That's it. Frequencies are 3, 4, 5, 7, 9, 8. Summation F. We call this total as summation F. Summation of frequency column is 36. Fine. Now understand what is an issue with this. This is data about weights. Can anyone tell me weight is a discrete variable or a continuous variable? Is weight a discrete variable or a continuous variable? It is a continuous variable. Why continuous? Understand? Because weight can be in decimal points also. Weight can be 48.6, 48.9 also, right? So what will be a problem here? Understand? If we get a student having weight as maybe 52, then that is okay, we can put him in this class, 49 to 53. But let's say we get a student having weight 48.6, then do we have any class right now here in this data which contains 48.6? See, this ends at 48, this starts at 49, so there is no class which contains 48.6, so will not be able to include such student, right? So in case of continuous data, we cannot keep classes like this. We have to make classes continuous. We have to make classes continuous. Good evening everyone. I'm getting some messages right now. Okay. Now understand, these classes right now, 44 to 48, 49 to 53, classes or groups, these are non-continuous. Non-continuous. This is called as mutually inclusive classification. Mutually inclusive classification. That means non-continuous or discontinuous. Sorry. Non-continuous classification. In that, lower value of each class is called as lower class limit. That is 64, 69, 59, 54. These are called as lower class limits, and upper values are called as upper class limits. Whereas, can anyone tell me, can we use this classification for continuous data actually? Okay, this is data, this data is continuous and we have used it, but tell me, is it correct, is it logical? Because now we are going to get a problem that if we get a student with 53.6, 53.8, then there is no class which contains 53.8, right? So we cannot include him. That is why we cannot use this kind of classification for continuous data. So for continuous data, we have to make the classification mutually exclusive. Mutually exclusive classification. What is mutually exclusive classification? Correct. No, correct. What is mutually exclusive classification? That means continuous, where classes are continuous. Why we call it mutually exclusive? I'll tell you. First, let's prepare continuous classes. Understand. This class ends at 48. This starts at 49. So let's take average of 48 and 49, which is 48.5. So we'll end this at 48.5 and we'll start it at 48.5 itself. Again, this ends at 53, this starts at 54. So average is 53.5. That means if you observe, we are taking class limits. Upper class limit, we are adding 0.5. Lower class limit, we are subtracting 0.5. Okay, so first value also we can predict. Instead of 44, it will be 43.5 now. Convert everything like this. 58.5, 58.5, 63.5, 68.5, 73.5. Let me know if everyone is clear up to this point. Continuous classes. Why do we call it mutually exclusive classification? Now understand. Because the problem is now, let's say we get a student with weight exactly equal to 53.5. Can anyone tell me, should we include that student in the second class or third class? If we are getting weight exactly as 53.5, where should we include him? Second class or third class? Anyone, any idea? I'll wait for you because again, I'm getting a bit lag in comments, Weight 53.5. Understand, we include it in third class because third class, that is correct, because we say that upper value is excluded. Third, correct, upper value is excluded. That is why it is called as mutually exclusive classification. In mutually exclusive classification, we call lower value as lower class boundary and upper value as upper class boundary. And upper class boundary is excluded from each class. It is included in next class. That is why third will be the correct answer. So this continuous classification will be better or more appropriate for continuous data. Let me know if everyone has understood this. I think there is a bit of lag in this. Let me disconnect and connect once again. Okay, fine. Okay, so these are upper class limits, lower class limit, upper class boundary, lower class boundary. Always understand, for any calculation we use boundaries always, not this. If anything is given in limits, you have to convert it to boundaries and then only you can make further calculations. One more point which we can calculate from this is class mark. Class mark is midpoint of the class. Midpoint means upper value plus lower value divided by 2. Okay, either way, either limits or boundaries, it does not matter because anyway their average is going to be same. Okay, if you see 44 plus 48 by 2 is how much? 46. And if you take average of these two, that will also be 46. So class mark is midpoint of the class, which is 46, then 51, 56, 61, 66, 71. Check whether everyone has understood up to this point. Then one more thing which we can calculate is relative frequency. Relative frequency means what? Understand. Total is 36. So we say that first class's frequency is 3 by 36. A relative frequency. For second class, relative frequency is 4 by 36. For third class, 5 by 36 and so on. That is called as relative frequency. In other words, I can say it is f upon summation f. Frequency of that class divided by total of frequencies, 7 by 36, 9 by 36 and 8 by 36. Of course, then ideally total should be 1, 36 by 36, right? This concept will be useful in probability chapter. We have used it, if you remember. In probability chapter, this concept is used while defining probability using relative frequency approach. Okay, there is a relative frequency approach in probability where we use this concept. Let me know once whether everyone is with me up to this point, whether everyone is clear up to this point. Let me know once. Next is percentage frequency, which is just relative frequency written as percentage. So it will be just relative frequency into 100, relative frequency into 100, percentage frequency. That will be 3 by 36 into 100. How much? 8.333%. Then second will be 4 by 36%. 4 by 36 into 100. You can just press percentage button on calculator. 11.1 recurring percent, and so on. That is called as percentage frequency. Obviously its total is 100%. Fine. This is kaha use hota hai? Okay, this is used in, I hope you remember, Rishwaraj, relative frequency definition of probability. ऐसा कुछ होता है शायद. Okay, I think there is something like relative frequency definition of probability, right? Maybe. Where we use this relative frequency. ठीक है. Okay, we need to see 2-3 more columns. So let me erase some of the columns now. I'm erasing class mark. I'm erasing relative frequency. And this also. Understand now. That is where we'll use this, Rishuraj, relative frequency definition. Wherever we have to take a percentage of total or how much percentage is a class with respect to total, we'll use this concept. Okay, fine. Next one is cumulative frequency now. Cumulative frequency. One is less than equal to type, other is greater than equal to type. Less than type cumulative frequency and greater than type cumulative frequency. Understand what it is. This concept is used in median, which we'll see tomorrow. Less than less than type frequency means what? How many values are less than 48.5? So that is 3. Then how many values are less than 53.5? Now less than 53.5 means both the classes, 3 plus 4, 7. How many values are less than 58.5? Which is again all 3 classes, which is 7 plus 5, 12. Okay, let me know if everyone has understood this. And then tell me further values then. 3, 7, 12. We are just adding next value if you observe. What will be next values, anyone? Huh, 7, then 12. After that, anyone? After 12, is it 19, then 28, and then 36? Obviously this has to match. 36. Is this clear to all? बाकी लोग सो गए क्या? सानिका, चंदू, यशोदन, आकाश, प्रेम. Those who were active in chat. Good. 19, 28, 36 and so on. Fine. Greater than type means opposite. How many values are greater than 68.5 in last class? So 8 values. So we'll keep on adding from the end. 8 plus 9 will be 17. 17 plus 7 will be 24. 24 plus 5 will be 29. 29 plus 4 will be 33 and then 36. This should match. है. Okay. Let me know if everyone is clear with cumulative frequency. If yes, we have to see only one last point in this frequency table. We can go to diagrams then we can be done with the chapter. Fine. So let's go to last part, frequency density. I'm erasing this cumulative frequency now. Now understand what is frequency density. For understanding frequency density, we'll have to see one concept called as class length. Understand? Class length or class width means difference between its upper boundary and lower boundary, not limit. Difference between upper boundary and lower boundary. That means class length, here it will be same for all classes. If you see 48.5 minus 43.5 is 5. This is also 5, 5, 5. Understand? So class length is 5 here. We have to calculate frequency density now. Frequency density is frequency upon class length. That means this tells us which class is more crowded, in which class there are more frequencies, in which class there are less frequencies. Okay, frequency upon class length. For example, if you see, this will be 0.6, 0.2, just a second, 0.8, then 1, then 1.4, 1.8, 1.6. This is called as frequency density. This tells us that this class is more crowded. See, as compared to class length of other classes, this class is more crowded, this class is more crowded, this class is more crowded, whereas these two are less crowded. Okay, that is what this frequency density tells us. This concept is used in histogram. Okay, we'll see what is histogram and how to use it. But everyone, let me know if you are clear up to this point. If yes, we can go to diagrams now, which is the last part of this chapter. Okay. Assuming everyone is done, let's go to diagrammatic presentation. This is again important from MCQ point of view, also theory point of view a bit. First, let's see diagrams for non-frequency data specifically. Clear? Okay, good. So non-frequency data. First diagram that we'll see is line diagram. Line diagram is when XY points are plotted and we just draw a line joining these points. We have seen this in some other chapter. Can anyone tell me for which data this will be more useful? For which type of data this will be more useful? Line diagram. Anyone? It is useful more for time series data, right? Since it shows us trend. That is correct. So time series data is where we use line diagram more because it shows us trend. For geographical series data, this will not make much sense because then in geographical data there is no increase or decrease, right? If we write Maharashtra, Goa, Gujarat, then there is no increase decrease in that. If we change the sequence, that is going to change. So time series data is where this will be more useful. If we have two data sets with same unit of measurement, then we use something called as multiple line diagram. For example, if we are plotting sales also and profit also, then we'll plot them in different colors, multiple lines. Then if we have two data sets and different unit of measurement, like for example, we are plotting number of units and rupees, sales in units and sales in rupees, then we use multiple axis line diagram. multiple axis line diagram, which is where we plot two axes, one for rupees, one for units. From theory point of view, this might be relevant. And last one is, if we have wide fluctuations in the data, that is some values are 2, 3, 4, 100, 200 and some values are 2 crores, 5 crores, then we use ratio chart or log chart, where we take log of each observation so that the diagram is smaller and then we can fit it in a single graph. So time series data, multiple line diagram, multiple axis line diagram, ratio chart. Second type of diagram is bar diagram. Second type of diagram is bar diagram. In bar diagram, again, a vertical bar diagram, which looks like this, is used again mainly for time series data, and then maybe for cardinal data also, score of each student, marks of each student and so on. Okay, so but mainly time series data, right? Over the years, what is the production, what are the sales. And horizontal bar diagram is generally used. Horizontal bar diagram means like this. This is generally used for geographical series data. You might have seen polls on TV. Yes, no, don't know, right? That is geographical data, that is spatial data, data divided over space. So there we can use horizontal bar diagram, or it is also used for qualitative data. How many students are wearing which colors t-shirt? Blue t-shirt, how many students? Green t-shirt, how many students? For that we can use horizontal bar diagram. All this is very important from theory point of view. Horizontal bar diagram, either geographical series or qualitative data. Again, in bar diagram, we have multiple bar diagram where there are more than one series and same unit of measurement. We have multiple axis bar diagram where there are multiple series and different unit of measurement. This is also called a subdivided bar diagram. And we have last one, which is divided or percentage bar diagram. Where all the data is converted to percentage and then every bar is of 100% height. Every bar is of equal height. And of that we divide into components. Maybe A is this much, B is this much, C is this much, A, B, C. Then A, B, C and so on. But every bar's height is 100%. That is called as percentage or divided bar diagram. Okay. So that is line diagram and bar diagram. There is one more name for line diagram actually, which you should note: histogram. Okay. This might come in exam, you should not be confused. Histogram is also another name for line diagram. Let me know if everyone is clear up to this point. Is everyone 100% clear up to this point? Let me know. I'll wait till then. Bolo. If yes, then we'll go to last diagram, which is simple, of this non-frequency. Is everyone clear with this? Clear? Yes? Okay, good. Yes, good. सोने वाले लोग? Clear. Third is pie chart for non-frequency data. This is used mainly for geographical data. What is a pie chart? You must have seen it somewhere. A circle is divided into various parts. Okay. Like for example, this is based on angle, we divide this. Total central angle of circle is 360 degrees, right? Total central angle is 360 degrees. So, nice, okay. Let's take an example. For example, we have a data. Sales in Maharashtra are 20 lakhs. Sales in Goa are 40 lakhs. Sales in Karnataka are 200 lakhs. And sales in Gujarat are 100 lakhs. Not 100. No, fine. Let's take some other states. Maybe states in MP, sales in MP are 40 lakhs. Sales in UP are, let's say, 50 lakhs. So we have these many states. This is a geographical data or spatial data. How to plot it on a pie chart? आज के पेपर के बाद, fine, after today's maths paper, it is difficult to sleep, right? Let's see, we'll discuss in class. Fine, what is total of this? Can someone tell me? Fast. अब तक आना चाहिए था. Total. मुझे ही करना पड़ेगा क्या? 450 total है शायद. 450 is the total. Now what we do is, we have to find a central angle if we want to plot this in a pie chart. If we want to plot this in a pie chart, we have to draw a central angle. So central angle is 360, we know, right? So just cross multiply. If 450 is 360, 50 is how much? Just like a ratio. For 450 we have 360. So for 50, how much? Can you just cross multiply and find this ratio, everyone? Find ratio for all. Find central angles. That will be how much? For last one it is 40 degrees, I think. Check for each one. I have to wait, I know. Fine. So 40 degrees. The next one, how much? 32, I am going from below. This one will be 80. This one will be 160. This one will be 32. This one will be 16. So that is how we have to draw central angles. That is, for Maharashtra we'll draw 16 degrees angle. For Goa we'll draw 32 degrees and so on. Then that will complete a circle, that is called as pie chart. Pie chart is simple. Some calculation question might come based on pie chart. Remember. Fine. Okay. So anyone, any other doubt? If not, let's go to last part of the chapter. Last part of the chapter, which is diagrams for frequency data, especially for continuous data. Because for discrete data we can use non-frequency diagrams also, like bar diagram we can use. For every student we can plot his marks. For frequency data especially for continuous data, we need following diagrams now. First diagram that we'll see is a histogram. Histogram is also called as area diagram. Now understand very carefully. Correct, इस पे numerical आ सकता है. Numericals can come from pie chart. Fine. Histogram or area diagram, understand very carefully now. Histogram is like a bar diagram, but it is for continuous data. Like for example, if we have a data like this, classes and frequency, 10 to 20, frequency is maybe 5, 20 to 30, frequency is 10, 30 to 40, frequency is 15, and 40 to 50, frequency is 10. So in histogram, what we do is, we plot X classes here. We generally don't plot frequency here. Okay, if we plot frequency, what will happen? Let's see first. But generally we don't plot frequency. If we plot frequency, how we do it? 10, 20, 30, 40. 10 to 20 frequency is 5. So we draw a bar like this. 20 to 30 frequency is 10. So we draw a bar double of this, 10. 30 to 40 it is 15, so maybe a bar up to this. And 40 to 50 it is 15, so sorry, it is 10, so up to this. That is called as a histogram. Histogram is a bar diagram with continuous classes. But we don't plot frequency on that. Okay, here it was okay. Ideally, we should plot frequency density on this. Okay, Rishuraj, I'll tell you an example, no issues. Till then, can someone tell me what is frequency density in this case? Frequency density is frequency upon class length. Frequency upon class length. Can anyone find frequency densities for all these values? Class length is 10. So frequency density will be 5 by 10, which is 0.5. 10 by 10, which is 1. 15 by 10, which is 1.5. And 10 by 10, which is 1. Check whether everyone has got these frequency densities. Yes. Correct. 0.5, 1, 1.5, 1. Now, even if we plot frequency density here, this diagram will have similar shape, because just instead of 5 we'll write 0.5, instead of 10 we'll write 1.0, instead of 15 we'll write 1.5. Still it is going to be same, 5, 10, 0.5, 1 and 1.5, right? The shape is going to be same. However, now x-axis shows classes or class widths, and y-axis shows frequency density. X-axis shows class width, y-axis shows frequency density. Understand very carefully. For each of these bars or each of these rectangles, its area can be calculated as length into breadth. That means x-axis into y-axis, which is frequency density, which is class width into frequency density. So we are calculating area of each bar as x into y, right? Length into breadth, or base into height, which is class length into frequency density. But what is formula of frequency density? Class length into frequency density means frequency upon class length. So we can cancel this and we get that area of each bar is equal to its frequency. That is why this diagram is called as area diagram. In histogram, always remember area of each bar is equal to its frequency. That means this area will be 5. This area will be 10. This area will be 15 and this area will be 10. Okay. In histogram, frequency is not plotted on y-axis. Frequency is the area of the bars. We plot frequency density on y-axis. Okay. Let me know if everyone is clear with this histogram. Done? If yes, then let's go to next diagram. Let me know if everyone is understood till then. Tab tak let me erase this. Got it? Okay, good. Fine. Okay, good. Next diagram then. Next diagram that we can use is a frequency polygonal. Now I'm writing it here only, but understand it is a different diagram. Frequency polygon. Frequency polygon. What is a frequency polygon? Frequency polygon can be obtained by joining midpoints of histogram when class lengths are same. Understand, this is important. When class lengths are same, 10 to 20, 20 to 30, 10, 10, 10, 10, we can obtain frequency polygon by joining midpoints of histogram and then joining it here on x-axis. That is why we get a polygon. Polygon means a closed figure of certain number of sides. Okay, so we are getting a closed figure. It is closed on x-axis and then it is joining midpoints of histogram. That is called as a frequency polygon. Frequency polygon can be plotted only when classes are of same length. Classes are of same length. Because if classes are of different length, then histogram looks different. Then we cannot join that. Then that does not make sense. So frequency polygon is this. Correct, joining of midpoints of histogram. Fine. Is this clear? Let me draw a frequency polygon for example now. Let's say we have a frequency polygon like this. Let's say we have a frequency polygon like this. Now understand very carefully. If we have a lot of values, then this frequency polygon starts looking like a curve. This frequency polygon starts looking like a smooth curve. Okay. If there are a lot of values, instead of just 5-10 classes, if we have thousands, lakhs of classes, then the frequency polygon starts looking like a curve, smooth curve, which is called as frequency curve. So frequency curve is what? We say that it is limiting form. Limiting form, that means where classes, number of classes tends to infinity of a frequency polygon or histogram. Obviously, because histogram and frequency polygon are actually same. Frequency polygon is just joining midpoints of histogram, right? So if we take very much values, a large number of data, then that histogram or frequency polygon starts looking like a smooth curve, which is called as frequency curve. Okay. Now frequency curve can be of any shape. However, according to module, frequency curve is only of 4 types. So we have to remember it like that only, because from exam point of view, we'll have to take 4 types only then. According to module, frequency curve is only of 4 types. That is what you have to write. One is bell-shaped. Bell-shaped frequency curve looks like this. Bell-shaped frequency curve looks like this. That means in middle there are more values in middle, or more values near average. Okay, more values near average, and less values near extreme points. More values near average and less values near extreme points. That is called as a bell-shaped curve. We can see such kind of curve in weights, heights, right? Because generally people having average weight or height are more, and generally over and under people are less in number, right? We have also used this bell-shaped curve in normal distribution, if you remember. Fine. Second type of frequency curve as per module is U-shaped curve, like this. U-shaped curve. That is, more values are near extremes. Okay, more values near extremes and less values near average. More values near extremes and less values near average. That is called as a U-shaped frequency curve. Now, can anyone give me an example of U-shaped curve? Sanika Marx was an example of what? This bell-shaped. That might be correct, not necessarily correct. Okay, but it might be correct. What does this sound? I don't know. Okay, fine, but that might be correct, because if the exam is like moderate, then average students will be high, low and high students will be low. But if it is CA exam, then the curve might look like this, right? Now people having less marks are more, people having more marks are less, right? So can anyone give me example of U-shaped curve? U-shaped. Cost curves, good. See, cost curves are U-shaped. Which cost curves? If you remember long run average cost curve or short term average cost curves, they are U-shaped, small u or a big one, right? So LRAC or SRAC curves are U-shaped. That is correct, good. What else? Generally, curve of traffic, or traffic means what? Actual traffic on roads. That is also U-shaped, because in the morning there is high traffic, in the evening there is high traffic, but in the afternoon there is low traffic, right? Fine. So we can take such examples for U-shaped curve. That is okay. Third one, according to module, third one is J-shaped curve. J-shaped. Reviews is also correct. Reviews also looks U-shaped. Reviews means what? Generally on Play Store or in Amazon, 5-star and 1-star reviews are more. Generally 3 2 stars reviews are less if you observe. Because people don't bother to give 2-star, 3-star. Either they give 5-star or they give 1-star or they leave it. Right? So generally this curve looks U-shaped. On Play Store or Amazon, if you observe, generally it looks like this. Generally, not always. J-shaped means what? Like J, right? So something which decreases first and then increases higher later. Any idea? Any example of this? Any example of J-shaped curve? Anyone? Any example of J-shaped curve? Okay. Understand, just like we saw traffic. If we take traffic between only some part, like traffic from early morning to maybe 10 11 a.m., then that will be increasing. Okay, because then that will be increasing. Supply, okay, supply curve looks like this. Generally that is correct. Good. Supply curve looks like this. Population might look like this. That is correct. If population is generally has increasing trend, then it might look like this. That is also correct. Good. Fine. That is good. Accidents. Why accidents, Rishiraj? Actually, curves of accidents, Rishiraj, will look like this, because that follows a Poisson distribution, if you remember, right? So it is positively skewed. Curve of accident should look like this. Is it clear, Rishiraj? And then last is mixed curve. Let me know, Rishiraj. Last is mixed curve. Mixed curve is anything then. Like whatever. Other than that, U-shaped, bell-shaped, J-shaped, whatever it is, we call it as mixed curve. Fine, correct. Cost curves look like this. That is correct. That is correct, Nidhi. You have seen this in economics. Good. So mixed curve is anything else other than U-shaped, bell-shaped, J-shaped. Now it is wrong to classify frequency curves in these 4 parts, but okay, module says so. We'll also say that. Last part of the chapter is cumulative frequency curves, or ogives. Cumulative frequency curves or ogives. Now understand what is it. Let's say we have classes and frequency. Let's say we have classes and frequency, or maybe x values and frequency 1, 2, 3, 4, 5, and frequency is given as 10, not 10. Let me take small values. 1, 3, 4, 2, 3. What is cumulative frequency less than type? Cumulative frequency less than type. It will be 1, 4, 8, 10, 13. Right? And cumulative frequency greater than type. Cumulative frequency greater than type will be, if we come from downwards, 3, 5, 9, 12, 14. Okay, total was 14. I wrote it as 13 by mistake. Sorry, this should be 13. Correct. That should be 13. Now, cumulative frequency curves are what? When we plot 1, 2, 3, 4, 5, when we plot cumulative frequency on y-axis. How? Let's say we have 2, 4, 6, 8, 10, 12, 40. So if we want to plot less than cumulative frequency, it will be 1, then 4, then 8, then 10, and then 13. So it will look like this. Whereas if you want to plot greater than type cumulative frequency, it will look like 13 first, then 12, then 9, then 5 and 3. So this was less than type cumulative frequency, this was greater than type cumulative frequency. These cumulative frequency curves are used in finding partition values. We'll see that later in next chapter. But till then, just remember that this is cumulative frequency curves, that's it. Anyway, we don't have to draw them in exam, but they might ask you to analyze. They might give you a curve and ask some questions on that. We cannot say. Okay. Anyone, any doubt up to this point? Let me know. Does anyone have any doubt? If not, then let's stop for today. I hope this chapter was clear. Yesterday and today was purely theory. So I hope this is clear to everyone. There are not much numericals in this, only on relative frequency, cumulative frequency, frequency density, percentage frequency, that's all. There's no other numerical in this chapter. So if this is clear, then very good. Then let's tomorrow we'll start with next chapter, which is Central Tendency and Dispersion. 148 matlab means Rishuraj, that was answer. Sanika ne jo 148, 10, 13 she has put, that is answer to that cumulative frequency. Fine. Okay. Then if there is no doubt, okay, then let's stop for today. We'll meet tomorrow at 9. Tomorrow we are going to start with Central Tendency and Dispersion, which is very important from calculation point of view, because you need to study how to save time in that. So bye everyone. Good night. Good night.